R is a high-level programming language, but what does that actually mean? Well, it means that it provides tons of prepackaged functions which you only need to program in accordance to your needs. That makes it much easier compared to low-level languages like C, where you have to tell the computer bit by bit what it should do. Plotting a histogram is as simple as typing hist_x in R. That would be impossible in C. Now, your responsibility as a programmer has shifted from building a function totally from scratch to programming a prepackaged function. You do this by feeding information into the function via the function arguments. Each function has a set of arguments which you can use to tailor it. So if we take a look at the function runif, we can see that it is a random number generator of a uniform distribution. You will find this function often together with rnorm for random numbers of a normal distribution. This function is quite useful when you want to try out new R features and you need some random data. Especially in forums like Stack Overflow, it is used to create data to explain a concept, and you can use it to show a question or a problem you might have. So this function runif has 3 arguments, as you can see here. We have n, which is the number of numbers we want to generate, and we have the minimum and the maximum for our uniform distribution. So those are the upper and lower boundaries. So far so good. Those are the infos we can use to tailor the output of the function. Now you should be aware of the fact that A, the exact order of those arguments is very important, and B, some of those arguments are mandatory while some are optional. Let's use this function and let's elaborate on our statements. The first thing we're doing now is we will set a seed. This means that each time we run the random number generator, we will get the same result. Would we not set a seed, we could not reproduce the results, since runif has a random component. Of course, if you're not using a random sample generator, you do not need to set a seed. Most of the functions have no random component, therefore a seed is used only infrequently. Therefore, we now use the function set.seed, and we are setting seed number 65 here. You can basically use any integer. In this case, I tell R that it should use its 65th random number variation. So the whole thing is not completely random. Behind the scenes, it's actually pseudo-random. And then we are using our runif function. So here we are saying that we want random numbers according to the uniform distribution. We want 9 of those numbers, which is indicated by n. We want a lower boundary of 3, the minimum value, and the maximum value should be 6. So those are the 3 arguments, as we can see in the help section over here. We are using it in our code to get this output down here in the console. We have 9 numbers, none is lower than 3, and none is higher than 6. Now, this method allows everyone instantly to see what you did. The arguments are clearly denoted. The full spectrum of arguments is used, and the order is exactly as in the help section. But what happens if we would write the exact same code but we would omit the name of the arguments? So let's run the next line without the argument. This one has the same input. Keep in mind that we are using the exact same order of the arguments here. And indeed, in the console we get the exact same results. R knows the order of the arguments and it will automatically assign the values to the arguments based on the respective position within the function. That means for you, when you know the order of the arguments and you stick exactly to that order, you do not need to name the argument. That means shorter code, less typos, and less time. Very important info for you guys. Now, what would happen if you use the full argument names, but you mix the order of those arguments, like we do here? We're using the n argument as the last one instead of the first one, like it would be the correct form of the function. Well, if we run the code, we can see that we get the exact same result. It works. That means as long as you tell R which value should be assigned to which specific argument, you can go with any order you want. Logically, if we would use the same order as above, but we do not assign the arguments to the values, we would get a totally different result. Here we are telling R that we want 3 numbers between 6 and 9, which is of course totally different than the previous input. Alright, so far we provided info to all the 3 arguments. But what happens if we only want to set one argument and we want to leave some others blank? Well, R can handle that in many cases. As you can see in the help section, we have default values for minimum and maximum, that is 0 and 1. That means if you do not provide inputs for those 2 arguments, R will provide a 0 for the lower boundary and a 1 for the upper boundary. So let's test that. Let's run RUnif with a number of 3. And indeed we get 3 numbers between 0 and 1. Again, 3 was the only value we provided. 0 and 1 was provided by R per default. So keep in mind that whenever you see default values on the R function description, this would be the info provided to the function if you do not do it yourself. Only the arguments without defaults are mandatory, which is for most functions the first argument with the input data. Now there is actually a little trick when you want to use the default setting for some arguments and you want to set them yourself for others. Let's say in this case we want 3 numbers with a lower boundary of 0 and an upper boundary of 4. So we are fine with the minimum value, but the third argument, maximum, needs to be changed. So we are typing 3 for n, then we are leaving the second spot empty with those double commas, and the third spot is again filled with 4 for the upper boundary. And this works perfectly fine, as you can see here. We get 3 numbers with a maximum of 4 and a minimum of 0. So that is the meaning behind the double comma. It makes sure that the input values are assigned to the right arguments. Alright, so let's recap what we learned in this lecture. We learned that the function is controlled by the user through arguments. You assign values to those arguments and R gets you the output based on those arguments. The help section is a crucial part when using a function for the first time. It tells you which arguments you can use. It tells you the order of those arguments, and you can also learn the default settings for those arguments. As long as you keep the order, even by using double commas as placeholders, so as long as you keep the order, you can even omit the argument name. Fortunately, our base functions have similar structures most of the time. You will find that x or data denotes the input data for a given function, and this will be the first argument most of the time. You will also find that the formula argument is used in some instances, for example with a box plot or a linear model. The interesting part is that especially the newer add-on packages have their own syntax, which is consistent within a certain package but is very different to standard R code. If you take a look at ggplot2, you will find that this whole system, and don't get me wrong, it's very successful. So this system can be seen as a totally new programming language within R, something like a domain-specific programming language. It is a new syntax within a specific part of R. Hadley Wickham, the creator of ggplot2, even has some other packages like tidyr or dplyr that are somewhat different to R and all have their own structure of arguments. Hadley surely knows what he is doing and produces quality add-on packages, so it's always worth taking a look at his products. But you will always get the feeling that he has his own way of doing things, and you will need some time to get familiar with his packages. They are very consistent within the package, but not within R as a whole. Again, this is crucial and fundamental knowledge in R. As soon as you know how to work with functions, you have full access to the power of R. Note that it does not matter if the function you want to use has a dozen arguments or only one. The fundamentals are always the same.